This is lesson 1.2.7 when we're talking about compound probabilities, and compound usually means when there's more than one, kind of like in science you have compounds when two elements are joined. So compound events are a combination of outcomes. When you have compound events, means you have a probability of one thing happening or the probability of another thing happening. And we're going to learn today how we deal with those. So we're setting up our notes. So first of all, you are given this page, and this is 1, 2, 7, and this is compound probability. Okay, so here's what we're talking about. We have Thomas, who helps around the house. He helps his aunt, who he lives with, and she spins this spinner on the right to tell whether she or which chore he's going to do for the day. Okay, so all these different chores, they take up a different piece of the spinner, and that means they have different probabilities. So here's what Thomas knows. He knows that rake leaves and do the laundry are the same size, so these two right here, and clean the bathroom and vacuum are the same size. And let's go ahead and mark that information so we know that these two right here are the same, and we know that these two right here are the same. All right, and our first question is, what is the probability that Thomas will do laundry? Okay, so we're looking at this spinner. What is this probability right here? This is the one that we're trying to figure out. Okay, so in order to find out this probability right here, we need to know something. We need to know, just like the missing spinner, we're going to be doing a lot of those, is in order to know this probability, we need to know the rest of the probabilities and just kind of use it as a complement. In other words, we take it away from 100. Okay, so once we know all of these probabilities in this whole spinner, we will be able to tell how much is left through subtraction. Right? So let's go ahead and find out all of these different probabilities. So the first one we have is vacuum. We know is 1/4, and since clean the bathroom is the same, we know cleaning the bathroom is also 1/4. And cleaning the bedroom is 1/3, but we still don't know rake the leaves, so we wouldn't be able to find that out. Okay, but we do know something. We know since both these are the same, we can find out all these probabilities right here and then find the missing 2. And since they're the same, we can do something mathematically to find the missing laundry. All right, so first thing that we're going to need to do, let's see, this is question number 1, 119. We need to know the probability of doing the laundry. All right, so the probability of laundry, we know that we have to take these 3 fractions and add them together so that we can find this missing portion, right? So that is 1/4 plus 1/4 plus 1/3, and that will tell us the probability of bathroom plus vacuum plus the bedroom, right? And this is going to be what's not missing. Okay, we do know these 3. So once we add them together, we should be able to tell what laundry is. So let's go ahead and add those up. First thing we need to do, we need to find a common denominator. So let's go ahead and change all these fractions. Common denominator is 12. So we're going to find, what are these fractions out of 12? Okay, this is the least common denominator. All right, so we start with the 1/4. We have times 3 times 3, that gives us 3/12. 1/4 again, and then 1/3. Okay, so that's 4/12. Now we have enough information to add those fractions. So let's go ahead and add. And by adding, we're finding out what the probability of these two after we find those combined. So we have 3/12 plus 3/12 plus 4/12, and that equals 3 and 3 is 6, so that's 10/12. And keep in mind, this is what's not missing. Okay, so 10/12 is not missing. Now, in order to tell what is missing, okay, so we're going to take the rest of the probabilities. How many 12ths are left if these three take up 10/12? We have 2/12 because we're finding the complement. So that leaves 2/12 for these two here. Okay, and since laundry and raking the leaves are the same, and together they make 2/12, we would divide by 2. Okay, we'll cut it in half. So both of those together are 1/12. So the probability of doing laundry is 1/12. Okay, so we find what's not missing, take it away from a whole, and then we find out what is missing. And since these two are the same, that's just what we did. All right, so the next question is, he really does not like cleaning the bathroom. So what we're going to do is we're going to find what is the probability that he is not going to clean the bathroom. What is the probability he's not going to clean the bathroom? Okay, now again, that's the complement of cleaning the bathroom. So first, let's look at the probability of cleaning the bathroom. Cleaning the bathroom is 1/4. So the complement of that would be, let's take 1 whole, which is 4/4, and take away the probability of cleaning the bathroom, and what's left? Right? So 3/4 is the probability of cleaning the bathroom. Okay, and this is the complement of cleaning the bathroom. Okay, and that's a very important concept, the complement. We always take it away from 100% in order to get that complement. All right, let's move on to the next question. Okay, Tom's aunt hopes that he will either clean the bedroom or rake the leaves. She really likes when his bedroom is clean and when the yard is clean. So what is the probability of bedroom and rake leaves? All right, so let's look at that. This is number 120. The probability of bedroom, we'll just put bed, is 1/3. But since we know we're going to do something to combine these a little bit, let's put the 4/12. All right, so 4/12 is the probability of bedroom. And then the probability of raking leaves, since we already find out the laundry is 1/12, we know that raking leaves is also 1/12. So we're going to put that for the probability of leaves is 1/12. Okay, now the question is asking, what is the probability, what is the probability that he will spin either one of the chores? Okay, so what they're asking is, what is the probability of getting either the bedroom or the leaves? Okay, now in order to find that out, let's look at what that means. So first, if I spin the spinner and I land here, am I cleaning the bedroom or doing the leaves? No. If I land here, no. If I land here, am I doing the bedroom or raking the leaves? Yes. In this side of the spinner, yes. And that side, no. So all three of these are a no, but that one and that one are both yes. Ant will be happy if he lands on this one, and Ant will be happy if he lands on that one. So we can take this whole section and say, this is what's going to make his Ant happy. And how do we find the probability of that section? We're going to add these two probabilities. Okay, so finding the probability of bedroom or leaves means that we are going to find the sum of the two. Okay, and that's a very important concept. Whenever you see the word or, that means that they both kind of apply, right? So this is the sum of the two. So let's go ahead and find out what that is. So first, the probability of bedroom we know is 4/12, and the probability of raking the leaves is 1/12. So that is 4/12 plus 1/12. So the probability of either getting one or the other is 5/12. That's a probability of bed or the leaves, okay? Because that is the sum of those two probabilities. Okay, and that's what we do to find missing parts of a spinner. Okay, so keep these notes, hold on to these notes. You will need them whenever we do missing spinner problems, and you need a little support. So our next question is Miss Nguyen lets her students borrow pens and pencils when they have a quiz. She has a paper bag that contains hundreds of wooden pencils, mechanical pencils, and blue pens that students randomly draw from. Stuart forgot his pencil, and it's quiz day. Miss Nguyen says one out of every 3 students who reaches into the bag gets a wooden pencil. 2 out of every 5 students pull out mechanical pencil, and the rest is a blue pen. So before we make sense out of this, let's try to understand it. So this is number 121. Okay, so we know that the probability of a wooden pencil is 1 out of every 3 students get one, so that's a probability of 1/3. And 2 out of every 5 students gets a mechanical pencil when they reach in. So mechanical pencil has a probability of 2/5. Right? So we have 1/3 and 2/5. We also know that the probability of getting a pen is the rest. Okay, that's just what's left over is the probability of getting a pen. So we'll find that out later. Okay, now, first question, Stuart reaches into the bag without looking. Is it more likely that he'll choose a wooden pencil or a mechanical pencil? So which one of these is more likely? Okay, so we're comparing them. And one way to compare them is, well, let's see what it would be if they have the same denominator. Right, so 1/3 and 1/5. What is the least common denominator? Is 15. All right, so we're going to change 1/3 to 15ths. So remember, you can use the giant 1 and do 1/3. What do I multiply it by to get 15ths? All right, 3 times 5 is 15, so 1 times 5 is 5. All right, so that's 5/15ths. And then the probability of mechanical pencil times 3 times 3 would be 6/15ths. So which one is more likely, getting a wooden pencil or getting a mechanical pencil? Right, getting a mechanical pencil is more likely. All right, and the next question, how can you describe the probability that he'll pull out some kind of pencil? Some kind of pencil means it's either mechanical or it's a wooden pencil. Okay, so let's phrase it that way. Since we know what that is, we're trying to find out what is the probability of getting a wooden pencil or a mechanical pencil. So what are they asking us to do? All right, if you guessed, well, we need to add those probabilities, then you are correct because we see this magic word right here. So this means we're taking the probability of a wooden pencil and we're adding it to the probability of a mechanical pencil because of that magic word right there. So or means that we are going to take the sum of it. We're going to add the two probabilities. Okay? So in other words, find the sum. So let's go ahead and find those probabilities. So we just change them. We have 5/15 and we have 6/15. So let's go ahead and find out what is the probability of getting any pencil. Wooden pencil plus mechanical pencil. Probability of any pencil is 11/15. Okay, so this is the probability of any pencil. 11/15. Now, I'm going to ask you another question. What is the probability that he gets a pen? All right, and that what I'm asking is pretty much the complement of any pencil. Okay, so the probability of getting a pen would be, since 11/15 is the probability of getting a pencil, what's left are pens. So we go 15/15 minus 11/15, and you get 4/15. Okay, and again, this is the complement of getting a pencil. Right, and if you remember what complement is, complement of getting a bathroom, cleaning the bathroom, its complement would be not getting the bathroom. Okay, so again, very important concept. This is the complement when we subtract from one whole.